Welcome to Earth and Beyond series. Today we're exploring the fascinating world of space weather and how solar storms impact life on Earth. From dazzling auroras to disruptions in technology, the sun's activity has far-reaching effects. Understanding solar flares, coronal mass ejections, and their consequences helps us better prepare for their impact. Let's dive into the science behind these powerful space weather events. The sun is a constantly changing star. Deep in its core, nuclear fusion converts hydrogen into helium, releasing immense energy. This energy radiates outward and fuels a turbulent surface, creating sunspots, solar flares, and powerful eruptions. Sunspots appear as darker, cooler patches on the sun, formed by intense magnetic activity. When magnetic energy builds up and is suddenly released, it causes a solar flare, a burst of radiation so intense it can disrupt communication signals and satellites in space. These flares release the energy equivalent of millions of hydrogen bombs within minutes, sending waves of radiation outward into space. Among the most powerful solar events are coronal mass ejections, or CMEs, massive bursts of charged particles and magnetic fields that surge away from the sun at incredible speeds. A single CME can hurl billions of tons of solar plasma into space. If a CME is directed toward Earth, it can reach our planet in a matter of days and disturb our magnetic field, leading to geomagnetic storms. These storms are capable of interfering with satellite operations, disrupting radio communications, and even overloading power grids. In extreme cases, they can cause widespread electrical blackouts. But not all solar activity is destructive. One of the most breathtaking effects of solar storms is the aurora. When charged particles from the sun enter Earth's magnetic field, they are guided toward the polar regions, where they collide with gases in the upper atmosphere. This interaction produces shimmering waves of light, known as the northern and southern lights. The colors of auroras depend on the type of gases involved. Green and red hues come from oxygen, while nitrogen produces blue and purple tones. These natural light shows are not just beautiful, but also a visible reminder of the sun's influence on our planet. While auroras are mesmerizing, the effects of space weather can be far more disruptive. Strong geomagnetic storms have the potential to interfere with modern technology. In 1989, a particularly intense solar storm caused a massive blackout in Quebec, Canada, knocking out power for millions of people. Satellites orbiting Earth are especially vulnerable, as they have no atmospheric protection against solar radiation. Disruptions to satellite signals can impact GPS accuracy, telecommunications, and even air travel. Scientists constantly study these events to better predict and mitigate their effects. To protect our infrastructure, scientists monitor the sun's activity using advanced space observatories like NASA's Solar Dynamics Observatory and the European Space Agency's Solar and Heliospheric Observatory. These satellites track solar flares, sunspots, and CMEs in real time, allowing scientists to predict potential impacts on Earth. By improving space weather forecasting, we can take preventive measures, such as temporarily shutting down sensitive equipment, rerouting flights, or strengthening power grids to minimize damage. Researchers are also developing new shielding technologies to protect satellites and electrical networks from intense solar radiation. From the beauty of auroras to the challenges of solar storms, our sun's activity influences life on Earth in ways we are still discovering. As we continue to explore space weather, we gain a deeper understanding of our place in the cosmos and how to prepare for the sun's unpredictable outbursts. Thanks for watching Earth and Beyond. If you enjoyed this episode, don't forget to like, subscribe, and share your thoughts in the comments below. Until next time, keep looking up.